Whether it's true or not, it's irrelevant. Piling on red herring after red herring will never amount to useful evidence. Pay attention, and soon you'll run into another claim supported with proof by verbosity. It might be another conspiracy theory. It might be an advertisement for a new type of water with medicinal properties. It might be an herbal product claiming to detoxify your body. Look at all the wild claims they make and take careful note of how many of them are actually directly relevant and specific enough to be testable. Notice how it would be impractical to try and respond individually to each of these many claims. It's an endless game of whack-a-mole. The only way to win? Don't play. Virtually every pseudoscientific claim credits some form of energy. Life force, chi, negative energy, positive energy, the body's energy fields. All meaningless nonsense, which sound plausible simply because they throw in a scientific-sounding word, energy. New Age practitioners seem to think that energy is a hovering, glowing cloud that can go wherever it's needed and from which adepts can draw power and feel rejuvenated or accomplish healings. Imagine a vaporous creature from the original Star Trek series, and you'll have a good idea of what New Agers think energy is. Energy is a measurement of something's ability to perform work. Given this context, when spiritualists talk about your body's energy fields, they're really saying nothing that's even remotely meaningful. Here's a good test. When you hear the word energy used in a spiritual or paranormal sense, substitute the phrase measurable work capability. Does the usage still make sense? There's a good reason you don't hear medical doctors or pharmacists talking about energy fields. It's meaningless. This is usually a really frail excuse for why mainstream scientists don't take their claim seriously, why the product is not approved by the FDA, or why scientific journals won't publish their articles. You'll often hear this in the form of a conspiracy of the medical establishment to suppress a quack cure because it's in the interest of the medical industry to keep you sick. In fact, any doctor or pharmaceutical company that could develop a new cure would make a fortune. They'd never suppress it. The same goes for auto manufacturers worldwide who are said to be suppressing new efficient engine technologies. As much as some people with particular ideological agendas would like you to believe it, science never suppresses good science. As we've seen time and time again, by no definition can all natural mean that a product is safe or healthy. I'm standing next to a gigantic stand of poison oak. Consider other all-natural compounds like hemlock, mercury, lead, toadstools, box jellyfish neurotoxin, asbestos. Not to mention a nearly infinite number of toxic bacteria and viruses, E. coli, salmonella, bubonic plague, smallpox. For those natural compounds that are not harmful, synthetic versions have been engineered in many cases to make them even safer, more effective, or able to be produced in large quantities. All natural? Often that's a great thing. Just as often, it's not. Some claimants suggest that it's moral, ethical, or politically correct to accept their claims, to redirect your attention from the fact that they may not be scientifically sound. In some cases, such as the anti-vaccine or anti-fluoridation activists, proponents try to use the court system to force their beliefs to be adopted in place of what we've learned through science. Generally, when a theory is scientifically sound, even if it's brand new, it will eventually find its way into the educational curriculum. Good science is done in the lab, not in the courts, not in protest marches, not in blogs, and not on Oprah. A political or cultural campaign to legalize or promote some product or claim is a major indicator that it's bogus. When you learn to identify these warning signs, and many others like them, this list is certainly not complete, you'll find that you start seeing them everywhere. And if you're having a conversation with someone who's trying to convince you to try some herbal therapy or New Age meditation, you can point out these fallacies in their arguments, and it strips them of the tools they depend on the most. Now that we understand what to look for, let's try applying these skills to some actual claims out there. But keep in mind that critical thinking must not be just about debunking. There's no benefit in debunking for its own sake. Rather, debunking is only necessary when pseudoscience stands in the way of progress. And then, it's critical. Precognition is where you dream or imagine or foresee some event that later comes true, when there's no possible way you could have known about it. One of the stories of precognition you hear most often is of someone thinking or dreaming about another person, only to find later that that person died at that same moment. It sounds like proof positive that there must have been some psychic connection. French physicists Georges Charpak and Henri Broche made a neat calculation to show that this is not only possible, it's inevitable. On average, it should happen to about 1 in every 150 people sometime in their lifetime.
Assume that everyone knows about 10 people who die each year, either family, acquaintances, or mostly celebrities and famous people. People who might pop into your thoughts no more than once a year. There are 105,120 5-minute intervals in a year in which each of those 10 people might die. That gives a 1 in 10,512 chance that you'll think about someone during the exact same 5-minute interval in which they happen to die in any given year. That doesn't sound very probable by itself, but consider that there are 300 million people in the United States. This improbable coincidence must happen to about 28,500 Americans every year. Only a tiny percentage of those get their stories on television or in print, but it's enough to convince an uncritical layperson that precognition and psychic connections must be real. And when you relax the criteria even slightly, you think or dream about someone, then next time you talk to them you find that something unpleasant has happened in their life, the probability goes up exponentially by a factor of millions.
The mathematics behind this concept universally apply to all pseudosciences that depend on extraordinary coincidences for their support. The law of large numbers, the inevitability of improbable events, proves that the most bizarre coincidences are merely mathematical certainties. Understand the math. Don't turn first to paranormal explanations. Next, let's consider complementary and alternative medicine. You'd think that with a century of modern medical science behind us, people would not still be looking to the ancient state of knowledge when it comes to their health. But unfortunately, it seems that the more things change, the more they stay the same. Just a tiny sampling of products and techniques still being sold, still in demand among 21st century Americans, and with no empirical or plausible hypothetical foundations. Reflexology, homeopathy, ionized jewelry, magnet therapy, therapeutic touch, colonic irrigation, chiropractic, herbal detoxification, vitamin megadosing, psychic healing, new age blessings, detoxifying foot pads and foot baths, naturopathy, aromatherapy, bioidentical vitamin therapy, chelation, radiology, psychic healing. You'll notice that these products are not FDA approved. It's legal to sell anything you want that's not overtly dangerous, so long as you don't claim that it is intended to diagnose, treat, cure, or prevent any disease or illness. And that's how billions of dollars of worthless supplements are sold every year. They usually claim that their product has wellness benefits, but in order to avoid running afoul of the law, they leave these claims uselessly vague, saying that their product restores balance, builds the blood, boosts the immune system, restores vitality, or some other claim that's medically meaningless, but that sounds reasonable to an uncritical layperson. When a product does have merit and warrants FDA approval, this merit is established through a process called the randomized controlled trial, more commonly called a clinical trial. Now, a clinical trial is a very special process. It's very different from the way most alternative products demonstrate their effectiveness, which is through personal testimonials and studies. Spend 5 minutes browsing through Wikipedia and congratulations, you've just completed a study. Spend 2 minutes rubbing your chin thoughtfully and looking at the sky and you've just completed a study. You can now legally sell your product with the claim, "Studies show that this product will repolarize your energy fields."
Not good enough for the FDA. To conduct a randomized controlled trial, a statistician will select a sample size large enough to produce a significant result. Care must be taken that the test subjects are properly representative of the target population and not tainted by selection biases that might skew the results. The subjects are blinded, knowing as little as possible about what's being tested. They are randomly and blindly assigned to one of several groups. There may be a group that will receive the treatment being studied, a group receiving an established treatment, and always at least one control group receiving a control or placebo treatment. Test administrators are also blinded. This is called double blinding, such that they don't know what group each subject is assigned to, and whenever possible, they also don't know what the treatment is that they are administering. Everything is coded to avoid experimenter bias and to cancel out any effects like patients trying to respond the way they feel the experimenters want them to. The trial lasts long enough to satisfy the statisticians and the scientists. Finally, when the results are tabulated by a blinded statistician, this is called triple blinding, we get the results. The cloaks of anonymity are whisked aside, and we finally learn for a statistical certainty which treatments are effective and which are not.
When this process shows significant benefits for a new treatment, and the trial can be repeated by other experimenters and yields similar results, then and only then do scientists say that this is a product that works and is supported by evidence. Let's pick just one alternative medicine to examine in closer detail. Homeopathy. This is a system invented around 1800 intended to bring into balance your 4 basic bodily humors: blood, phlegm, yellow bile, and black bile, by ingesting an infinitesimally small amount of whatever poison caused the imbalance. Clearly, all of these fundamental assumptions homeopathy is based on are now known to be complete nonsense. Homeopathy is about extreme dilution. The greater the dilution, the more effective the treatment. A tiny amount of extract, usually from some herb, is diluted in water, far past the point of being chemically pure water. Early in the dilution process, they agitate it, and this is said to give the water a spiritual imprint of the original compound, and it can then be diluted infinitely without losing its effectiveness. This water is then sold as is, or is infused into sugar pills. Let's look at some of these. These come in pill form. These are standard sugar pills, same as you can get at a pharmacy. Sucrose and lactose are the only listed ingredients. Each pill has supposedly been infused with a single drop of the diluted water. Essentially, it's a very small hard candy without any flavoring. This one is a 30C dilution of sulfur. Now that doesn't mean 1 part sulfur and 30 parts water. It means C, or Roman numeral 100, to the 30th power, or 10 to the 60th power, which is 1 followed by 60 zeros. Chemical purity is related to Avogadro's number, 6 times 10 to the 23rd. So technically, this solution is 37 orders of magnitude more pure than chemically pure. This is far more diluted than 1 sulfur atom in all the oceans of the planet. How likely is it that there is even a single molecule of sulfur in this bottle? Impossible. It's pure sugar. This whole shelf in the pharmacy, simply pure sugar infused with pure water. If all of this stuff is actually unsupported by any good evidence, that doesn't mean that it doesn't really work. But lots of people believe that it does. Smart people, your friends and neighbors, and the professionals you work with. Well, let's look at some of the reasons smart people believe weird things. First of all, the unexplained is cool. Who doesn't love a fascinating subject? Whether it's the Loch Ness Monster or a black hole at the center of our galaxy, it's cool. Or what about a new meditation technique that will let you change your body's physical appearance? we're all naturally predisposed to be excited about